Bearing of a line, by definition, the bearing of a line L is the acute angle formed by the north-south line and the line L. Acute angles we call is between 0 degrees and 90 degrees. The notation begins with N as a north or S as a south, followed by the number of degrees in angle, and ends with E or W or east or west. For example, the position A is north 30 degrees east, north 30 degrees east. So either north or south. So this case is a north, and the line L with an angle 30 degrees. That tells you the position A. Another case, for example, the position D is south 80 degrees west. Go down south, go over 80 degrees to the line L. And this is the position D. The first example, a ship sailed from a port with a bearing of south 22 degrees east. How far south has the ship traveled after covering a distance of 327 kilometers? Let's draw the north-south east-west line. Let's origin as the port location. The ship sailed from a port with a bearing of south 22 degrees east. The question is how far south? We let it be x. How far south has the ship traveled after covering the distance of 327 kilometers? Over here is 327 kilometers. Let's form the right triangle diagram. 22 degrees, x, and 327 with the right angle here. We have x as the adjacent, 327 as the hypotenuse. Use a definition 2 to form the cosine of 22 degrees, which is the adjacent x divided by hypotenuse 327. Compute x by multiplying 327 both sides of the equations to get the number 303.19, or is approximately equal to 303 kilometers. That is the how far south the ship has traveled. The second example, a boat sails from a certain port in the direction north 30 degrees west. After the boat has sailed 20 kilometers, how far is it west of the port? Let the port is at the origin point. The boat sails from the certain port in the direction north 30 degrees west. North 30 degrees toward to the west. After the boat has sailed 20 kilometers, how far is it west of the port? So we are looking for the west direction. So let it be x. Again, draw the right triangle. If this is 30 degrees, so then the rest of them or the complementary angle would be 60 degrees. The boat traveled 20 kilometers. We are looking for the west distance. Let it be x. From this right triangle, x is adjacent, 20 is the hypotenuse. Therefore, the cosine of 60 degrees equals the adjacent x divided by hypotenuse 20, or x equals 20 multiplied by the cosine 60 degrees. From the exact value table, the cosine 60 is 1/2. 20 multiplied by 1/2 or 10. That means the boat has traveled 10 kilometers west from the port. In this example, a cyclist travels 10 kilometers south, then 8 kilometers east. Find the cyclist bearing from her starting point to the nearest degree. This time, the problem gives you the distance of the east and the distance of the north. Example 3. A cyclist traveled 10 kilometers south, then 8 kilometers east. Find the cyclist bearing from her starting point to the nearest degree. Let her starting point be the origin. The cyclist travels 10 kilometers south, go down south for 10 kilometers, and then 8 kilometers east. We are going to find the cyclist bearing from her starting point to the nearest degree. The bearing will be in the form of south and then an angle theta and east. We're going to find theta. Let's redraw the right triangle diagram. Angle theta, 10 kilometers south, 8 kilometers east. We have 8 as the opposite, 10 as the adjacent. Using the trig function, we use a tangent function. The tangent theta equals 8 over 10, which is 4 over 5. Therefore, the angle theta can be found by using the inverse tangent or the arctangent of 4 over 5. That gives us 38.66 degrees. The problem asks you to write as the nearest degree, so it's approximately equals 39 degrees. Therefore, the bearing will be in the form of south 39 degrees, east. Example 4. A ship leaves port at noon and has a bearing of south 24 degrees west. South 20 degrees west. The ship sails at 20 knots. Knot equals nautical miles per hour. How many nautical miles south and west will the ship have sailed by 6 p.m.? The timeline. The ship leaves the port at noon, and we are looking for the distance, the south distance and the west distance after 6 hours. After 6 hours, the total distance would be 20 multiplied by 6 or 120 miles. We are going to find how many nautical miles south and how many nautical miles east. Let x be how many nautical miles south and y be the nautical miles west. From the right triangle diagram, we have 120 as a hypotenuse, 24 degrees, y as the opposite, and x as the adjacent. We're going to find x, which is the number for the nautical miles south. Based on the hypotenuse 120 and an angle 24 degrees, we can use the trig function using the cosine. So cosine 24 degrees equals the adjacent x divided by the hypotenuse 120. Therefore, x equals 120 multiplied by cosine of 24 degrees, or we get x as 109.6, or approximately equals to 110 miles. So this is the south direction. And next we're gonna find y, which is the west direction. Y is the opposite. This time we're gonna use the sine of 24 degrees, which is the opposite y, divided by the hypotenuse 120. So y equals 120 multiplied by sine of 24 degrees, or we get y as 48.8 miles, or approximately equals 49 miles. And we can summarize as the ship will travel 49 miles west and 110 miles south from the port by 6 p.m.